So, I don't even know when you're going to watch this video. I think it's like Thursday or Friday night, but I'm making it here on this beautiful Sunday morning. So, this is one of the hardest topics we're going to talk about this year. Absolute value and absolute value equations. You're like, oh, I know absolute value. You take the positive that's inside the thing. Okay, that is not it at all. So, here we go. Absolute value. The definition of absolute value is the distance away from 0. So when you say the absolute value of x equals 5, that means on a number line, x is 5 units away from 0. So it could either be here or it could be here. So we would say x equals 5 or x equals negative 5. Because x is 5 units away from 0. Now, distance is always positive, so that's why you were always taught take the positive of what's ever inside. Because if x equaled negative 5, then the absolute value of negative 5 would still be 5, because it's 5 units away from 0. Negative 5 is 5 units away from 0. So it's really important that you understand that concept, that this symbol means distance away from 0. So let's try one. The absolute value of 2x minus 1 equals 5. That means this expression is 5 units away from 0. So it could be two possible things. We could say 2x minus 1 equals negative 5, or 2x minus 1 equals 5. Both of those are correct. So we solve both equations. Or so either x equals negative 2 or x equals 3. If you plug in negative 2, this is going to be negative 5, and the absolute value of negative 5 is 5. If you plug in 3, that's going to be positive 5, and the absolute value of positive 5 is 5. So x could equal either of these two numbers. Okay, so we would write that like in set notation like this. Try one on your own. Pause the video and try to solve that. You would write two separate equations. And your two possible answers are negative 2 and 2/3. Okay, now what happens when it gets a little bit harder? Well, sometimes you have more than one step. So before you set up your two equations in this situation, because we're not going to say 3 times the absolute value of x plus 2 minus 1 equals 8, 3 times the absolute value of x plus 2 minus 1 equals negative 8. We're not going to do that. We're going to isolate the absolute value. So we're going to get this by itself. So first we're going to add 1 to both sides. It's almost by itself. Then we're going to divide by 3. Now you've isolated the absolute value, you can set up your two equations. So either x plus 2, either x plus 2 equals negative 3, or x plus 2 equals 3. Wow, this marker's got to go. So minus 2 from both sides, x equals negative 5, or x equals 1. Now in your book it might say graph the solutions on a number line. All you would do is put 0 in the middle, 1, negative 5, and you would put a dot here and a dot here. Those are the two solutions. but you have to isolate the absolute value. Try one on your own. Pause the video and try this. Step 1 would be to minus 3 from both sides. Oh, I like this skinny pen because it likes my writing better. So your two equations would be x plus 9 equals 2 and x plus 9 equals negative 2. So x equals negative 7 or x equals negative 11 because you have to minus 9 from both sides. So x equals negative 7 or x equals negative 11. Okay, now sometimes you might get a solution that's called an extraneous solution. Let me spell that for you. This is going to show up a lot in this course, where you get an answer and it seems like it works, but then when you check it, it doesn't work. So with absolute values especially, you always want to check your answer and make sure it works. For instance, if we go back, if we plug in negative 7 up here, negative 7 plus 9 is 2. The absolute value of 2 is 2. 2 times 2 is 4, plus 3 is 7. That works. Here, if we plug in negative 11 plus 9 is negative 2, but the absolute value of negative 2 is positive 2, times 2 is 4, plus 3 is 7. So both solutions work. But what happens when you have a problem like this? So we know we have to set up two equations because our absolute value is already isolated. So we're going to say 3x plus 2. Oops, there's a little doohickey on my screen. Hold on. 3x plus 2 equals 4x plus 5. But remember, your other equation has to be the negative of that. So when you take the negative of a binomial, you have to put it in parentheses. Remember, a binomial is two terms. So this one's pretty easy. We're going to minus 3x, 2 equals x plus 5 minus 5, and x equals negative 3. That one's not bad. This one, however, 3x plus 2 equals negative 4x minus 5. I'm going to add 4x because I like to move the smaller x so that I always have a positive coefficient of x. So 7x plus 2 equals negative 5 minus 2. 7x equals negative 7. X equals negative 1. Now again, like we said before, we always have to go back and check our answers. So plug in negative 3 for x. 3 times negative 3 is negative 9, plus 2 is negative 7. Absolute value of negative 7 is 7. So this side is 7. Over here, 4 times negative 3 is negative 12, plus 5 is negative 7. These two things are not equal. So we would reject this solution. My teacher used to make me write extraneous, but I think that's a little bit overdoing it. So we're just going to say reject the negative 3. Let's check negative 1. 3 times negative 1, let me get rid of these 7s so we're not confused. 3 times negative 1 is negative 3, plus 2 is negative 1. The absolute value of negative 1 is 1. 4 times negative 1 is negative 4, plus 5 is 1. That works. This is your solution. Let's try another one. You guys are going to try this guy. Now, you're either going to have this homework on Thursday or Friday, which means you have the whole weekend to watch this video. Don't be lazy. Don't fast forward through it. Pause the video and solve the equations right now. You have to figure out what your mistakes are. Okay, so the first solution is 5x minus 2 equals 7x plus 14. The other one is 5x minus 2 equals negative 7x plus 14. So over here we're going to minus 5x, negative 2 equals 2x plus 14. I hope you can hear the lovely birds chirping out my door. It's so relaxing, so much better than taking notes in class, isn't it? Okay, sorry, off track. Minus 14. So now negative 16 equals 2x, x equals negative 8. That's 1. Over here, 5x minus 2 equals negative 7x minus 14. I'm going to add 7x, so 12x minus 2 equals negative 14. Add 2, 12x equals negative 12, x equals negative 1. But remember, we have to check both answers. I know it's a pain, I know it's more work, but you want to get the most possible points on any assessment. Check your answers. Okay, negative 8. 5 times negative 8 is negative 40. Minus 2 is negative 42. So this side's negative 42. But the absolute value of negative 42 is positive 42. Over here, 7 times negative 8 is negative 56. Plus 14, this is negative 42. So we're rejecting this one. Oh, I get it. You always reject the one on the left. What? No. Check your answers. Negative 1. 5 times negative 1 is negative 5. Minus 2 is negative 7. Absolute value of negative 7 is 7. 7 times negative 1 is negative 7. Plus 14 is 7. This one works. Okay? That's it for absolute value equations. Now we have to do absolute value inequalities. It gets even harder. Sorry. So, when we say the absolute value of 2x, let me start with an easy one. The absolute value of x is less than 5. That means the distance away from 0, is less than 5 units. So that means your solution has to be somewhere between here and here, in between, right? Because the distance is less than. So here you'd be less than 5 units, less than 5 units, less than 5 units. Here you'd be more than 5 units. So the distance has to be in between negative 5 and 5. What's another way of saying in between? Another way of saying in between with an inequality is the word and. So negative 5 has to be less than x, which has to be less than 5. X has to be between negative 5 and 5. So pick a number between negative 5 and 5, like 0. The absolute value of 0 is 0. 0 is less than 5. It works. Okay, so for less than, you want to be in between. What happens when we make this a greater than? Things get cray-cray. Okay, if I want the distance away from 0 to be bigger than 5, the distance away to be bigger than 5, that means I'm talking about all the numbers over here or all the numbers over here. The distance that this is away from 0 is about 7 units. That's bigger than 5. So this would be an OR problem. We would say x is less than negative 5 or x is greater than 5. You have to memorize that for absolute value inequalities, less than means and, greater than means or. Now if you don't want to memorize it, you just have to remember how to figure it out using this example. You guys like to memorize though, so that's probably what I would do. So let's try one. The absolute value of 2x minus 1 is less than 9. Less than. That means it has to be in between negative 9 and 9. So we're going to say 2x minus 1 is greater than negative 9, and 2x minus 1 is less than 9. Some people like to just do this. Say if I know it has to be in between 9 and negative 9, I'm just going to go like this and solve it that way. That's fine, but I'd rather see two inequalities solved separately. So here we're going to add 1, so 2x is greater than negative 8, and divide by that, so x is greater than negative 4. Add 1, so 2x is less than 10. Divide by 2, x is less than 5. So your answer is x is greater than negative 4 and less than 5. So we would write it like this. Negative 4 is less than x is less than 5. Or on a number line, we would say negative 4, open circle, 5, open circle, connect the dots. We always have to check our answers. What number is between negative 4 and 5? How about 0? That's the easiest one to check. 2 times 0 is 0, minus 1 is negative 1. Absolute value of negative 1 is 1. 1 is greater than negative 9 and less than 9. So that works. So this was a less than problem. We did and. You try one. Solve and graph. Pause the video, solve and graph. So it's less than, which is and. So we're going to do 3x minus 4 is greater than or equal to negative 8, and 3x minus 4 is less than or equal to positive 8. Solve your inequality. Now some of you here might be like, wait a minute, I thought when you divide by a negative you flip the sign. Remember, only if this number is negative. Okay, and then add 4, divide by 3. So to graph your answer, you would say here's negative 4/3, here's 4. I have to be bigger than this one and less than this one. Now some people like to say, oh, x is greater than or equal to negative 4/3, x is less than 4. This is actually wrong because the arrow doesn't tell the reader when to stop. So what you're really saying with this picture up here is all real numbers, because this goes on forever this way and this goes on forever this way. So this would actually be wrong. You have to connect the dots and stop at the two endpoints. Okay, last thing. Greater than. Greater than, greater than, greater than. 2x plus 4 is greater than or equal to 6. Now remember, greater than means on a number line, negative 6, 0, and 6. I want to be this way, that's greater than 6 away from 0, and this way, which is greater than 6 units away from 0. So I have to be less than or equal to negative 6, or greater than or equal to 6. Now I really hope some of you go back and listen to the explanation about why this one is or and the other one is and. It's kind of really important that you understand that. So 2x is less than or equal to negative 10, x is less than or equal to negative 5, or 2x is greater than or equal to 2, x is greater than or equal to 1. So on our number line we're looking at, oh, my dishwasher's done. Negative 5 less than is that way. 1 greater than or equal to is that way. You should always show 0 on your number line. That's helpful. That would be the solution to that inequality. Okay, last one by yourself. Pause and go. And you have made it through the longest, I think it's longest, it doesn't tell me how long it is, and most difficult notes for the whole chapter. This is it for the chapter, so after this we're just going to review and take a test. How's that sound? Like a plan? Alright, have a great weekend. Bye.